Go.
Hello, everyone. Welcome to Practical GCP's System Design Series. In this session, I would like to talk about an event-based batch ingestion design. First of all, as usual, I'll give an overview of the design and quickly talk about the benefits of it, and then I'll dive into some key areas that you would like to consider when using this design. And before I jump into the design itself, I would like to introduce two new Google services that have not been covered in previous sessions. So the first one is Cloud PubSub. So Cloud PubSub is a fully managed message queue system that on Google Cloud. So it's something that you can use to send messages or events into and also to use it for consumptions. So this is something really good for real-time landing of events and real-time consumption of those events. Cloud Function, you can just see it as somewhere you can run a piece of code. And this thing is also fully managed, serverless. You don't have to manage any servers around this area. You just have to focus on running the code. Cloud Function has very good integration with Cloud PubSub, and these two are very often used together for event consumptions. So for example, in this particular case, if an event gets ingested into the Cloud PubSub topic, and then you can create a subscription to trigger a Cloud Function immediately. So let's have a look at the design. In some scenarios, you may have third-party systems that would drop files to you, right? So those files could be dropped into a cloud storage bucket. And you may also have other use cases where you need to maintain reference data. So these are typically uploaded by humans. So in those two cases, then once the data landed into cloud storage bucket, there's some very interesting attributes that cloud storage can do. So at the files, when these files drop, if you have a look at the event types here, there's one thing called the object finalize event. So this is the event that gets generated and gets stored within Cloud PubSub. Then you can trigger a Cloud Function. Let's ignore these two boxes in the middle called relays, and I'll come back to that later. For now, think of the Cloud PubSub message landed will trigger a Cloud Function to run immediately, and the Cloud Function can then copy the files from the source bucket into the target bucket where we have here, and then also load the data into BigQuery immediately. So in here, in my opinion, you just need to use one Cloud Function because copying the files and loading to BigQuery are two very simple processes you can do. You don't have to overcomplicate it by having multiple Cloud Functions doing this particular case. So the BQ load is something I've already covered in the previous system design section. If you would like to know more, please have a look at the scheduling-based ingestion video. So the benefit is pretty obvious here. So assume the files gets loaded into the cloud storage bucket because the whole pipeline is based on events, right? So there's no scheduling based. As soon as something happens, the next step will be triggered immediately and so on. So the copying of the files from the cloud storage bucket into the target cloud storage bucket might take a little bit of time. And then so does the BQ load, but these are typically in seconds. So by the time a file has landed and the file's gone into BigQuery, you're probably talking about less than 10 seconds. So that's a huge benefit for some of these use cases where you need near real-time data. Now I would like to talk about a bit of the design on why, as you can see, there are two separations. I'll even put a line in the middle on having an external GCP project and also a centralized GCP service project. So this design is focusing on the left. The external project is you create the project specifically designed for third parties and other vendors to land data into the storage bucket. So these other third parties may even have their systems not sitting on Google Cloud. So they might have access to the tokens to be able to drop files to GCP. And then as these file events land, and that's the job finished for the external GCP project, there's no processing of the data, but only landing of the data, right? And then this is where it gets interesting. So instead of trying to mix it all up, and then deploy the whole pipeline in the external GCP project, we have this centralized service GCP project area where we can deploy a pipeline that can be reused across different initiatives. So as you can see here, that's why we created the relay. So the Cloud PubSub box here is another topic that sits inside the centralized service GCP project. And this is where the events can be relayed from the Cloud PubSub, the external one, into the ones that we have in the central place. And then from the pipeline all the way downwards, and that would allow us to create one kind of pipeline to handle any kind of buckets or events in a very generic way. The Cloud Data Flow job here, as I mentioned, is a Cloud Data Flow template. This is something, as you can see in this page, that Google already provided the template for you to relay messages from one PubSub topic to another PubSub topic. So this is very straightforward to deploy. You just need to deploy the template and it will just work on its own. In this external GCP project, this is all about handling third parties. You may contain, one third party in here. You may contain two third party in here. In some scenarios, you might even want to duplicate this whole thing here, right? In this particular case, you would have two external GCP projects for the separation of, because these are completely different kind of services or third party vendors. You just want it to be, you do not want them to be in the same place, right? So in this case, if you look at the design we have in the centralized side, you would need to deploy another data flow job to get the data relayed, right? Relayed into the centralized PubSub topic, right? This is another relay. And then this pipeline from this point onwards is completely generic because it doesn't matter how the files dropped into where, the function to load the file based on the data that stored in the PubSub topic will be completely generic, right? This is we don't need to deploy another pipeline to handle this exactly the same workload. So this is why the decoupled approach to have the centralized project in here is much more powerful than try to deploy everything all together in the same project. I would like to talk a little bit more about the external cloud storage and permissions handling and the TTLs in here. So this is where I'm referring to. So when you have third-party systems, especially in some scenarios where you might have two third parties in the same project, right, in this design. So it's definitely not a good idea to try to give all of these third parties and users the same access level to be able to read on the whole project, because then you have things mixed up, right? People can see each other's data. So the first important thing is to make sure everything is bucket level. Each one of these use cases or vendors would have their own bucket. But in addition to the bucket level access itself, we also want to make sure each of those areas can only upload the data, right? So this is why we've in here mentioned we're only giving storage object creator. What this means is each one of those third parties can drop the data into cloud storage. But after they've done that, they cannot read it, they cannot change it, they cannot delete it. Even if something has gone wrong, right? So you have another level of protection, because if, let's say, these two third parties can see each other's bucket for whatever reason, because someone made a mistake, and then they would only be able to upload data into that bucket. So something would stop working because things go a little bit wrong, but you still cannot read each other's data. So this gives you an extra level of protection. So the TTL here is you never want to store data in here permanently, right? Because of many reasons. One of the key things is this is temporary data. We want to copy across into somewhere else that we own in our own area, but we don't want to store this for a long time. And so typically you may set this TTL to a day or a couple of days, then the data disappear automatically. So this is very important not to keep this data in here for a long period of time. And the reason we're copying data from the source bucket into our own bucket, but not moving it, is typically because when you're doing this copy or move operation, you are very often changing the format of the data, or the path where it stores, or even the name of the files, right? So in that operation, that if something goes wrong, if you move the whole thing instead of copying it, you already lost the original name of the files. So it's very difficult to trace back to what the problem it caused, because this code could have done something else as well, right? So it will be a lot easier to keep this for a short period of time. Then if something does go wrong, then you can compare the files in here and the files in here, then you know what is the problem. So finally, the thing I would like to cover is this solution has pros and cons. And obviously, there will be use cases where you want to use it, but there's also be use cases you probably don't want to use it. So for the use cases of the third-party data coming in, it would be quite useful for things like when you have a known schedule in this area, so you don't know when the file is going to come in. It could be in the morning, could be in the evening, it could be once a week, right? You don't know when it's going to come. And then also it could be intraday data. So the data could arrive hourly, it could arrive every 15 minutes. So it's quite difficult to catch these things with schedules. So in this case, it's a lot easier to use the event-based systems because you don't have to check when the files has landed or not. On the manual side, this is extremely useful because for reference data where pretty much every company has it, in order to upload data into somewhere that you can manage those reference data that typically managed by humans. So this is the process. You never know when the data is going to be uploaded. So it is very effective to use the event-based approach. So as soon as someone uploads the file, within 10 seconds or 20 seconds, it will be loaded all the way into BigQuery. So there are also use cases that you may not want to use this design. So let's say if the third party is sending you, I've actually seen this happening quite a few times, is they send you huge amount of small files. So let's say you have a CSV file or a JSON line file, or just individual JSONs, right? So those files are probably only has a few lines of data, a few rows in each of those files. But then you have hundreds of thousands of them coming in every single day. And if that is the case, you'd hit with this particular issue straight away, because the BQ load job can only do 100,000 in a day, right? So if you have so many small files, not only this is going to be extremely inefficient because you're loading them one at a time, you are also going to hit this quota, which means as soon as you do that, you cannot load any more files. And that's going to be a very big problem. And the other thing is around whether this is an overcomplicated solution, right? So you would want to have this solution in there to solve some kind of problems as a one generic pipeline. But then in a lot of the scenarios, the files gets ingested are not very time sensitive to be loaded into BigQuery. So let's say if there's 100,000 of files coming in every day, but you don't know exactly when they come in, but it will be sometime around that day, maybe every hour, maybe every 15 minutes. But all you care about is by the end of the day, you want them into BigQuery. So what you could do is just wait until the end of the day, or load it 2 to 3 times in a day, and then load this into BigQuery, right? And then your solution becomes a lot more efficient because instead of, because the event-driven system is based on processing every single file, right? Every single event at one at a time. But if you use, instead, in my previous video, I introduced about the scheduling-based ingestion. You can load 100,000 of those files all at the same time using one BQ load job. And then that would complete in, let's say, maybe 10, 20 seconds to load the entire thing into BigQuery. So not only that's more resource efficient, cost less, but also it's a lot easier to manage in those scenarios. So hopefully this is useful. Thank you very much for watching, and see you next time.
Go out!